It consists of rocks and metals. It is made up of 5 main layers. The crust is where we live. Next comes the upper mantle or the asthenosphere. Next is the lower mantle, followed by the outer core. And lastly is the inner core. Earth has a diameter of 12,756 km. Let us now learn about the depth of each layer. Starting from the innermost layer, the inner core extends up to 1300 km. The outer core extends up to 3500 km. Mantle, including both the lower and the upper mantle, extends up to 6400 km. The crust varies from 5 to 50 km in depth. The Earth's interior consists of rocks and metals. It is
divided into concentric layers based on mechanical properties and its composition. Nobody has ever reached the interior of Earth. A question then arises in everyone's mind. If no one has reached the Earth's interior, then how do we know about Earth's internal structure? Most of the information about Earth's interior is gathered through indirect sources. Let us explore the interiors of Earth in this module. Source of information. The knowledge about the interior of Earth is very limited. Maximum information is gathered through indirect sources. Among these indirect sources, seismic waves are the most important. The sources of information regarding the Earth's interior can be classified into 2 parts. 1. Direct sources and 2. Indirect sources. Among the direct sources, the important ones are volcanic eruption and mining areas and drilling projects. Among the indirect sources, the important ones are seismic activity and gravity force. Direct sources. Volcanic eruption. Magma, which comes out during volcanic eruption, is used in laboratory for research and analysis. Mining areas and drilling projects provide information through the analysis of materials collected at different depths. The information gathered is limited to Earth's crust. They provide information like temperature increases at the rate of 1 degree Celsius for every 32 meters of depth. The radius of Earth is about 6,378 kilometers. The deepest point is about 12 kilometers deep. The deepest mine on Earth is the Tortona mine of South Africa, which is 3.8 kilometers deep. The deepest bore well is the Kola Super Deep borehole in the Kola Peninsula in Russia, which is about 12 kilometers deep. Indirect sources. Gravitational force. The gravity of Earth pulls objects towards the center of the planet. It gives information about the distribution of mass of the material in the Earth's crust. All objects that have mass attract each other with a gravitational force. This force is directly proportional to the masses of 2 objects. If the mass is double, the gravitational force will also be double. Seismic activity. Seismic waves are the series of vibrations on Earth's surface. They are caused by sudden rupture within Earth. The rocks along a fault tend to move in opposite directions. As the overlying rock strata press them, the blocks get deformed and eventually they slide past one another. This causes a release of energy. These energy waves travel in all directions. They help to determine the internal structure of Earth. There are two types of earthquake waves. 1. Surface waves, which travel only on the surface of the Earth. And 2. Body waves, which travel deep beneath the Earth. Let us get a clear concept of surface waves first with the help of an animation in the next slide.
Motion in the surface waves is usually larger than that in body waves. Therefore, surface waves tend to cause more damage. Surface waves travel a little slower than the shear wave and are classified into two types: Rayleigh waves and Love waves. Rayleigh waves move both vertically and horizontally in a vertical plane pointed in a direction in which the waves are traveling. Amplitude of waves decreases with the depth. Material returns to its original shape after the wave is passed. Love waves move the ground from side to side in a horizontal plane, but at right angles to the direction of propagation. Their amplitude decreases with the depth, and the material returns to its original shape after the wave is passed. Motion in the surface waves is usually larger than that in body waves. Therefore, surface waves tend to cause more damage. Surface waves.
Now, let us try to understand body waves with the help of an animation.
The motions detected on the surface of the Earth are called earthquake waves. These are divided into body waves and surface waves. Body waves travel deep within the Earth and are classified into two types: compressional waves and shear waves. Compressional waves are also known as P waves or primary waves. These waves move faster and reach first at surface of the Earth. These waves travel through solid as well as liquid. These waves move through the mantle and the core. The shadow zone of P wave appears as a band around the Earth between 105 and 145 degrees away from the epicenter. They move through material by squeezing and stretching the material in the same direction as the wave is moving. Shear waves, also known as S waves or secondary waves, travel only through the solid material. S waves are unable to pass through the outer core of the Earth due to it being liquid. The shadow zone of the S wave is much larger than that of the P waves. It is not only larger in extent, but it is also a little over 40% of the Earth's surface. S waves move material at right angles to the wave direction and make the Earth shake from side to side. The motions detected.
Test yourself. At how much distance from the surface is the deepest point of Earth located? The options are A. 10 kilometers, B. 11 kilometers, C. 12 kilometers, D. 13 kilometers. The answer is C. 12 kilometers. Earth's surface. The answer is C. 12 kilometers. Explanation. The deepest point is about 12 kilometers from the surface of the Earth. It is Kola Super Deep borehole in the Kola Peninsula in Russia. Earth's surface. The equatorial diameter of Earth is greater than its polar diameter. Also, the equatorial circumference of Earth is greater than its polar circumference. Earth's surface is primarily composed of rock, metal, and water. The shape of Earth is oblate spheroid. The surface of the Earth is solid and the temperature inside it increases with its depth. It is believed that Earth's interior is made up of molten material because of high temperature. Now, let us study about the different layers of Earth. Earth is divided by the mass of elements in a layered structure, somewhat like the layers of an onion. Let us watch an animation on the layers of Earth in the next slide.
The Earth's radius is about 4,000 miles or 6,400 kilometers. The main layers of its interior are the crust, mantle, and core. The thickness of the crust averages about 50 km under the continent, but is only about 5 km under the ocean. The density of the continental crust is 3 grams per cubic centimeter, whereas the density of the oceanic crust is 2.7 grams per cubic centimeter. The mantle is a highly viscous layer present between the crust and the outer core. The mantle is relatively flexible, so it flows instead of fracturing. It extends down to about 2,900 kilometers below the surface. The density of the mantle is 3.4 grams per cubic centimeter. Core is divided into two layers, the inner core and the outer core. The inner core is solid and is about 1,300 kilometers thick. The outer core is about 2,200 kilometers thick and is so hot that the mantle is always in the molten stage. The fluid contains iron, which on moving generate Earth's magnetic field. The density of the inner core is 13 grams per cubic centimeter, whereas the density of the outer core is 5 grams per cubic centimeter.
We will discuss all the three layers of Earth in detail now. Let us start with crust. Crust is the outermost layer of Earth. It envelopes its interior. It is brittle in nature. The average thickness of crust is about 60 kilometers. It is thick below the mountains and thin below the oceans. The crust consists mainly of silicon, aluminium, and magnesium. Earth's crust is divided into two parts. Oceanic crust, which is also known as seama. The deep ocean floor is about 7 kilometers thick and made of relatively dense rocks like basalt. 2. Continental crust, which is also known as sial. The average thickness of continental crust is 33 kilometers. It is composed of relatively light material such as granite. Mohorovičic discontinuity. Mohorovičic discontinuity is the transition zone between Earth's crust and the uppermost section of the mantle. It is named after the Croatian seismologist Andrija Mohorovičic. Mohorovičic discontinuity is also known as the Moho discontinuity. Now, let us learn about mantle in detail. Mantle is the middle shell which lies below the crust. It is about 2,900 kilometers thick. The temperature in the mantle ranges between 870 degrees Celsius and 2,200 degrees Celsius. It is largely made up of rocks and is partially molten. It is rich in magnesium and silicon. Mantle can be divided into the inner mantle and the outer mantle. Outer mantle. Outer mantle is found between 10 kilometers and 300 kilometers below the surface of the Earth. It is made up of rocks. The temperature in this layer is about 870 degrees Celsius. Inner mantle. Inner mantle is found between 300 and 2,890 kilometers below Earth's surface. It consists of sulfides and oxides of silicon and magnesium. The temperature in this layer is about 2,200 degrees Celsius. Gutenberg discontinuity. Gutenberg discontinuity is the boundary between the core and the mantle. It is named after the German-American geologist Bino Gutenberg, who defined this boundary in 1914. There is an abrupt change in the seismic wave patterns at the depth of 2,900 kilometers. It denotes a phase change from the solid mantle above to the liquid outer core below. Core. Core is the innermost layer of Earth. It consists of two parts. 1. Inner core, which contains solid nickel and iron, and 2. Outer core, which contains liquid nickel and iron. The pressure and temperature in this core is very high. Outer core. Outer core is located about 2,890 kilometers beneath the crust. Its estimated temperature is about 2,200 degrees Celsius. It is about 2,200 kilometers thick and is composed of melted metals, nickel and iron, known as Nephe. Inner core. Inner core is the innermost layer of Earth. It begins about 6,437 kilometers beneath the crust. It is about 1,200 kilometers thick and its estimated temperature is about 7,500 degrees Celsius. Inner core mainly consists of iron. The high pressure in the inner core crystallizes superhot iron into solid state. Earth as a magnet. The inner core. Earth as a magnet. The convective effect and rotation in the spinning liquid metallic core result in the formation of the electric current. This convection current generates magnetic field. Without magnetic field, the surface will not be protected from solar radiation and life will not exist on Earth. Earth's magnetic poles are not stable and they wander over Earth's surface. Test yourself. Where is the Gutenberg discontinuity situated? A. Between crust and the upper mantle. B. Between upper mantle and the lower mantle. C. Between lower mantle and the outer core. D. Between outer core and the inner core. Hint: second and third layer. The answer is C. Between lower mantle and the outer core. Explanation: Gutenberg discontinuity is the boundary between the outer core and the lower mantle. There is an abrupt change in the seismic wave patterns at the depth of 2,900 kilometers. It denotes a phase change from the solid mantle above to a liquid outer core below. Let us summarize the topic. Seismic waves are the most important source regarding information about the interior of the Earth. The two types of earthquake waves are surface waves and body waves. The Earth's surface is primarily composed of rocks, metal, and water. The three layers of Earth are 1. Crust, 2. Mantle, and 3. Core. Mohorovičić discontinuity is the transition zone between Earth's crust and the uppermost section of the mantle. Gutenberg discontinuity is the boundary between the core and the mantle.